Alright, last subtopic, which is on capacitors with dielectrics. So in this subtopic, you have to be able to define and use dielectric constant, describe the effect of dielectric on the parallel plate capacitor, apply capacitance of air-filled parallel plate capacitor, and lastly, determine capacitance with dielectric. So the capacitance of a parallel plate capacitor is proportional to the area of its plate. So if the area is bigger, the capacitance would also be bigger. And then it is inversely proportional to the plate separation. So the plate separation is basically this distance here. My cat. So if the plate separation is bigger, the capacitance would be much more lower lah. So the capacitance it depends on the type of dielectric insert between the two plates. So the capacitance is directly proportional to the dielectric constant lah. This is the symbol for dielectric constant. So for air-filled parallel plate capacitor, their equation is C naught equal to epsilon naught A over D. Okay, so E naught here is the permittivity of free space. The value is 8.85 times 10 to the power of negative 12 farad per meter. Okay, so if you can't remember it, don't worry, it is in your formula sheet. And then A is the area of the two plates here, area of the plate lah. And then D is the plate separation, which is the distance between these two parallel plate capacitor. For parallel plate capacitor filled with dielectric, which is an insulator, the equation changes from having just epsilon naught, it will have an addition of epsilon r here, which is the dielectric constant. So the dielectric constant will be given lah, dia bukannya a value yang you have to hafal. It's not a constant yang macam 8.85 gitu. It depends on the type of material lah. Okay, so dielectric ni actually is a non-conducting material. So it is an insulator which is placed between the plates of a capacitor. Macam di sini lah sekarang. So when it is inserted, it should increase the capacitance of the capacitor by a factor of dielectric constants, which is which is called the dielectric constant of the material lah, by a factor depending on the dielectric constant macam tu lah. So what is the advantages of using dielectric? It would actually increase the capacitance of the capacitor, increase the maximum operating voltage, and it acts like a mechanical support. It acts as like a mechanical support that allows the plates to be close together without touching, hence decreasing the plate separation and increasing the capacitance. Okay, so kiranya ni macam satu bridge lah, bridge yang it's not even touching, tapi dia help macam this electron can, I would say, jump. Okay, is it even logical? But basically, contohnya kalau kamu jump from across a bridge, it is much more harder to jump straight away here than by doing like this. So macam kiranya this dielectric material ni, it act like a bridge lah. So untuk supaya lagi dekat dia mau lompat. Macam tu lah. Lebih kurang macam tu. Kali lah. Okay? Tiap lah. Harap kamu faham je. So, how does a dielectric increase the capacitance? So, untuk the case of isolated capacitor, kalau battery sudah kena remove, charge on the plate will be constant lah. So, the electric field between the plates di sini ni masih lagi E naught. E naught ni maksudnya bila dia tidak dielectric material lah. Okay? So, lepas tu, when the dielectric is placed between the plates, sekarang ni ada dielectric material kena place between the plates. The dipoles orient themselves. So daripada dia semak-semak begini, tiba-tiba dia susun sudah diri dia macam ni. So dia susun lah, the positive will be attracted to the negative plates, the negative will be attracted to the positive plates. Okay, so because of what this charge is doing, a reverse electric field is created. Okay, so there, instead of going like this, dia bagi macam ni. So that is calculated using this equation here lah. So if you look at this, it's actually reducing the electric field. So when the electric field is reduced, the voltage is also reduced. And then for the capacitance pula, the voltage is reduced. When the voltage is reduced, the capacitance will increase. So dari situlah cara the dielectric increase the capacitance of the capacitor. Okay. Untuk the case when connection still remains, the electric field will decrease, so does voltage. But since it remains connected, charges tu masih lagi boleh flow until the voltage across the capacitor equals to the voltage of the power supply. Okay, so since they remain constant, the capacitance will increase sebab the charge is also increasing. Okay, so when the battery is disconnected, remember the charge will still be constant. When the battery is still connected, the voltage is constant. Okay, ini konsep lah that you just have to understand. Alright. Untuk dielectric constant pula, it is epsilon R lah. It is defined as the ratio of permittivity of dielectric material and permittivity of free space. So yang ini kamu kena ingat lah formula dia. I don't really think it's given in the formula sheet. I'm not sure. I don't remember sudah. Tapi this is really important sebab if you come across a question that needs to use either of this, kamu kena ingat lah mana satu di atas, mana satu yang di bawah. So dibalik-balikkan. Okay. So this is the meaning of each of the symbols. Just have to read that through. And dielectric constant, dia tidak unit, dimensionless, and will always be greater than 1. Okay. It will always be greater than 1. Dia tidak boleh jadi 0.0 something. Maksudnya kamu salah kira lah. So different insulating material has different values of values of epsilon R lah. Untuk vacuum, it's just 1. Air is 1.000 lah. Macam ni lah. Some of it. Okay. Yeah, so that is the theory part of our subtopic number 3. Sekarang ni kita tengok dia punya example lah. Okay, so a parallel plate capacitor has plates of area 280 centimeters square separated by a distance of 0.55 millimeter. The plates are in vacuum if a potential difference of 20.1 volt is supplied to the capacitor. We have to determine the capacitance of the capacitor, the amount of charge on each plate, and the electric field strength produced. Okay, so information given is the area, which is 280 centimeters square. That is 280 times 10 negative 4 meters square, separated by a distance of 0.55. That is the plate separation. So that is 0.55 10 to the power negative 3 meter. The plates are in vacuum. Potential difference is 20.1 volts. So this is basically all the information that has been given, including the permittivity of free space, which is this one lah. Okay. So the capacitance of the capacitor is very straightforward. This is a parallel plate capacitor in air ataupun in vacuum lah. So maksudnya C is equal to E naught A over D. So sekarang ni we know that this is 8.85, 10 negative 12. Area is 280 times 10 negative 4. So this is over the plate separation, which is 0.55 times 10 negative 3, which will give you 4.51 times 10 negative 10 farad. Okay, so that is on the capacitance of the capacitor lah. Question B pula, it is asking on the amount of charge on each plate. So that is equal to QCV. So that C is the one that we've calculated earlier. And then V is 20.1. So this will give you 9.07 times 10 negative 9 coulomb. Okay, and lastly, the electric field strength produced. Remember, we have an equation that use V equal to ED. So this is E V over D. So that is 3.66 times 10 to the power 4 volt per meter. Okay. Alright, so that is on example number 4. Let me just check if I have include. I think that equation E equal to V over D is in chapter 1 na, kalau kamu lupa. But let me just double check just to be sure. I feel like it's this subtopic. E equal to this one. E is equal to V over D. V is equal to ED. So that equation is in chapter 1 lah. So basically, there's an overlap between chapter 1 and 2 yang equation yang kamu perlu guna tu lah. Okay? Alright, so that is on subtopic number 3 and basically the end of our chapter 2.